Welcome to Draggy Maths. How to find the product of binomials. What is a binomial? A plus b is an algebraic expression consisting of two terms, a and positive b. If we take a binomial and we multiply it by another binomial, we say we've got the product of two binomials. Where do we often use the product of binomials? Well, to calculate areas of shapes. Check it out. We've got a big rectangle consisting of a blue, a green, a red, and a purple rectangle. If we have to calculate the area of the big rectangle, it will be length times width. We can say it is just 6 units times 8 units, which will be 48 square units. Or we can break the rectangle up into 4 smaller rectangles and multiply separately. And this rectangle will be 2 times 3 units, 6 units. The green rectangle will be 2 times 5, 10 units. The red would be 4 times 3, 12 units. And the purple will be 4 times 5, 20 units. So you've noticed that we've multiplied each number in the one bracket by each number in the other bracket. And that will be equal to 48 square centimeters. So what did we do? We used the distributive law. We expanded the brackets. But what if we work with algebra? We've got the length of a rectangle, which is a plus b units. This means that this length from there to there is a units, and from there to there b units. So the total length is a plus b. The same with the width, c plus d. So if we want the area, we want to multiply a plus b, the binomial, times c plus d, another binomial. And we have to multiply each number in the one bracket by each number in the other bracket. And that will give us ad plus bd, b times d, plus bc, b times c, plus ac, a times c. There is a quicker way to do this, or a method that ensures that we multiply each number in the one bracket by the number in the other bracket. It is called the FOIL method. F stands for first terms. So we will multiply the first terms by each other. The first term in the one bracket, multiply the first term in the other bracket. That will give us AC. Then we'll multiply the outer terms. That will be the first term in the first bracket and the last term in the second bracket, a times d. Then the inner terms, do you see those two middle terms, b times c? And then the last terms in each brackets, the b times d. And that will give us the same answer, ac plus ad plus bc plus bd. This is called the FOIL method. How do we use the short method to square a binomial? So let's say we've got an a plus b times an a plus b. Do you see the two binomials are exactly the same? If we now expand, we'll see a times b gives us ab, b times b, b squared, a times a squared, and a times b, ab. What do you notice? We've got two perfect squares and then two like terms. Let's see what happens. So if we square a binomial, we can write it short like this. And then what happens is we square the first term, a squared, we square the second term, b squared. But how do we get this middle term? Notice we'll get two like terms that we just double. We'll double this term. That will give us 2ab. So in other words, a times b and double it, 2ab. So we multiply those two terms by each other and double the answer. So we square the first term, we square the last term, and we double the product of the two middle terms. This is an easy way or a short method to square a binomial. We can also use FOIL to square a binomial. We will get exactly the same answer. If we multiply the first, the outers, the inner, and the last terms, we will have an extra step though, because we will have to add the two middle terms, which are exactly the same. AB plus AB. What if we square a binomial, but the two terms are subtracted from each other? Well, almost exactly the same thing will happen. This a will give us a squared, but remember a negative b squared will give us a positive b squared. And then we'll have a negative ab and a negative ab, which means there are two negative ab's. Let's see what happens. So there is our binomial squared. So we square the first term, which will give us a squared. We will square the last term, a negative b times a negative b give us plus b squared. But now our middle term will be the a times the negative b, and we'll double it, and that will give us negative 2ab. How do we multiply binomials when only the signs differ? So we've got an a plus b times an a minus b. It's not squaring of a binomial, it's just exactly the same binomial but the signs differ. There is a shorter method, but first see what happens. If we expand the brackets, we'll get a negative AB, a positive B squared, a positive AB, and a positive A squared. So, what happens with a negative AB and a positive AB? That's correct. They are additive inverses. So those two terms will disappear and we'll end up with A squared minus B squared because the middle two terms are additive inverses. If we know this, there's a shorter way of dealing with this. We can just multiply the first terms by each other and multiply the last terms by each other. And that will give us the difference of two perfect squares. Do you see the two middle terms disappear? So let us practice. In this first example, this will just be a normal product of two binomials. There's not a shorter method for it. We can just use FOIL. So we'll multiply the first terms in each bracket. We'll multiply the outer terms. We'll multiply the inner terms, and we'll multiply the last terms. For the first terms, it will give us 2x squared. Outer terms, let's see, it's the 2x times the negative 5y, negative 10xy. The inner terms, the negative 3y times the x is negative 3xy. And the last terms is negative 3y times negative 5y. It gives us a positive 15y squared. Notice that we'll have like terms. And if we simplify the like terms, the middle two terms will give us negative 13xy. Example 2. Notice that this is the squaring of a binomial. We can write it short like this. How do we square a binomial quickly? Well, we square the first term, we square the last term. We take the product of the two terms and we double it. So 2x squared is 4x squared. Negative 3y squared, remember a negative times a negative is a positive 9y squared. If we multiply 2x by negative 3y, we get negative 6xy. And now we double it to give us negative 12xy. Remember, if you don't know this method, you can just use FOIL, but then you'll notice that you'll have in the middle a negative 6xy and another negative 6xy, and that will combine to negative 12xy. So remember, you can multiply the first terms, the inner terms, the outer terms, and the last terms, and you'll get the same answer. Example 3. Now you notice it's two binomials and they are exactly the same except their signs are different. So what happens here? Well, we know that the two middle terms will disappear and we'll end up with the difference of two squares, which makes it easy. We can just multiply the first terms by each other and the last terms by each other instead of using FOIL. And that will end up in 4x squared minus 9y squared. Let's see, we multiply the first terms by each other. The 2x times the 2x is 4x squared. And the last terms, negative 3y times 3y. And that gives us negative 9y squared. We don't have to multiply the inner and the outer terms because it will give us additive inverses. So let us summarize. How do we determine the product of binomials? Well, there are three methods and you can always use the FOIL method. The FOIL method is if you've got two different binomials, you can just multiply the first terms in each bracket, the outer terms, the inner terms, and the last terms. If you've got a binomial squared, you will square the first term, square the last term, and to get the middle term, you'll multiply the two inner terms or the two terms inside this bracket, and you'll double it. If you notice that you've got two binomials which are exactly the same except for the signs, then you only have to square the first term and square the last term, or multiply the first terms by each other and multiply the last terms by each other. You don't have to calculate the inner terms and the outer terms because those two will give you additive inverses.